Hello everyone, welcome to this video for CIV1281 asset management. And we are group 5, and here this is the video for our topic condition assessment of water and wastewater system. And here are our group members: Ran Gu, Yansheng Gu, Tong Rui Kang, Jiahao Tang, and Qian Zhang. And here are our table of contents, which includes the major topics for this video, which includes background of water and wastewater system, procedure of condition assessment, innovative data collection methods, the distinguishment between performance and condition, technology means, and finally AI approaches in asset management. Asset management plans play an important role in modern infrastructure, as AMPs can provide reliable benchmarks for maximizing asset life and distributing resources more efficiently. In order to collect sufficient information for AMPs, condition assessment is necessary to evaluate the real status of assets through inspections. In this video, we will formulate relevant technologies and procedures of condition assessment through a specific case in water and wastewater infrastructure. First, let me introduce the background of our selected specific condition assessment to explain why it is necessary. Deterioration of water and wastewater infrastructure over time has always been a major concern for municipalities, as the condition of water pipes highly determines quality of water and level of service. For instance, it was estimated that about 13.3% of treated water through Canadian distribution networks are actually lost through leakage caused by structural damage or faulty connections. A more surprising fact is that more than 50% of the leakage is caused by leaks from large diameter pipes, which only occupy less than 5% of total number of leaks within the system. Similar situations also take place in wastewater assets. Besides waste of water, these failures can also result in other potential risks, such as contamination to the environment and also to the surrounding infrastructure. These signals highlight the significance of condition assessment to make accurate evaluation and make necessary repair or replacement in time. However, there are still a large number of challenges and barriers to perform condition assessment. Lack of adequate data is one of the most common and fatal reasons. To be more accurate, around 41% of Canadian municipalities lack data of condition of their distribution pipes. Under such conditions, many municipalities over-rely on age-based assumptions, which frequently give misleading information. As a result, resources are often allocated to renew those assets that actually have remaining service life, while the real defects that require immediate repair or replacement are ignored. Achieving a balanced relationship between customers' expectation of quality and their willingness to pay is another huge barrier. In other words, the public perception may require enhancing service quality while rejecting to pay the extra servicing cost. Fortunately, many existing or emerging technologies are becoming available for more objective inspections and analysis of water pipes despite these barriers. In the remaining parts, we will provide more details to explain how innovative technologies can be used to solve the problem through the process. But first, in the next part, Yang Gu will talk more about the procedures of condition assessment.
Okay, thank you, Frank. And let's move on to the next part. Hello everyone, my name is Rangu, and now I'm going to deliver the process of the condition assessment. Based on research among the different facilities and infrastructures, the procedures of condition assessment can be generally summarized in the following 4 steps. The first step is to review all the information and construct the hierarchy of the assets. The second stage is determining the evaluation mechanism of the assets. The third stage is field inspection and data collection. And the last step is condition analysis. Before inspection and rating, all information the municipality maintains shall be analyzed, include the as-built drawings, the shop drawings, and the maintenance history. The key outcome for this stage is classify the knowledge gaps and divide the asset to components. And at the second stage, the inspectors will develop the condition scales to assess the infrastructure. As per recommended articles, as well as other Canadian water infrastructure case studies, there are several significant stages added to the condition assessment procedures. And firstly, when the building evaluation mechanism, the inspection team shall evaluate the risks associated with the failure of the asset. Since every failure is unique, one of the effective way to define the risk is build the matrix of the consequence of failure and the probability of the failure. And as a result, the risk assessment will provide ideas of which components to inspect. After the risk assessment, the team shall evaluate different approaches of inspection. The municipality will eventually choose the most suitable option of the inspection. The third stage is field inspection and data collection. The objective of this stage is detect and record the damage of the assets. Recording and analyzing the severities of the damage by inspectors or by other information collecting means. And the last step is condition analysis. The condition of the components are then evaluated based on different approaches, such as direct condition rating survey and distress survey. In this stage, the team will define the condition of the assets and whether the infrastructure achieved the desired level of service. The final results generated in the condition assessment are then usually put into asset management software and compared to other components of the asset management plans to determine what actions are necessary and cost-effective to attain the required level of service.
In terms of data collection, sufficient data is required to ensure the asset condition is captured, allowing appropriate assessment of the data and decision-making process. This involves gathering necessary quantity and quality of the data while remaining cost-effective, which imposes a challenge for data collection and condition assessment as a whole. Traditionally, there is an over-reliance on manual inspections through inspectors on-site and their eyes in the field. This method varies based on the experience of the inspector, human errors, and costly to maintain due to the labor cost and data entry. Therefore, this gap between data integrity and cost can be addressed through innovative technologies to enhance data collection. This include CCTV, zoom cameras, and robotics. First, CCTV cameras can be utilized to provide a visual inspection of the pipes for the operators. they're able to be deployed at locations that are inaccessible by humans. This technology also allows panning, tilting, and zooming, which further enables the operator with the flexibility to determine the area of interest. Furthermore, multiple data points can be gathered, including the presence of sediments and debris, pipe sags and deflections, evidence of cracks and leaks, as well as their locations. The limitation of this technology is that CCTV cameras can only be deployed within the pipeline above the waterline. Next is zoom cameras. These cameras are stationary devices, typically mounted by a pole, truck, or crane with the assistance of an operator on site. This is done by lowering a camera through the manhole to provide graphical information about the condition of the asset. This technology is intended to be utilized in conjunction with other data collection means to prioritize locations of interest for thorough inspection through the manholes. The limitation of this technology involves human operation. However, it is believed that the training required for operating zoom cameras will be less than the actual inspection of the pipeline, as well as reducing human errors. Additionally, there is a potential to miss defects due to bends and curves between manholes to manholes. Lastly, crawlers and tractors are mobile robotics that can be deployed into pipelines with a variety of different sizes for different diameters of pipes that can be also configured by mounting cameras and other multi-sensors such as sonar and laser, depending on the need of the inspection. This method provides a live view of the condition of the pipe while enabling the operator to control the unit remotely, allowing a safer and more reliable means of data collection. The limitation of crawlers or tractors can be their range, where typically this can be steered to inspect 300 to 500 feet of pipes. However, with the recent advancement, this can be extended with long-range robotics. The process of data collection, like many other aspects of condition assessment, is subject to continuous improvements, where the elimination of manual involvement such as on-site inspection can reduce delays, errors, and labor costs while increasing efficiency, safety, accuracy, and overall comprehensiveness of the data collected. Furthermore, the advancement of automation and image recognition systems, which can also be integrated into data collection, such as autonomous robots to determine and identify issues on the spot without the need of an operator. These advancements, along with the previously mentioned technologies, will definitely facilitate in continuously improving the process of data collection and overall conditional assessment.
Asset condition reflects the physical state of asset, such as physical damage, corrosion condition, fracture, which may or may not affect its performance. Asset performance is ability to provide the required level of service to customers. Generally, this can be measured in terms of reliability, availability, capacity, or customer demands. They both for determining the remaining useful life of an asset, and more importantly, the timing to bring level of service back to the desired standard. So, asset management team will make decisions based on asset's condition and performance. According to research, technology means of the condition assessment can be divided into direct detection method and modeling analysis method. The direct detection methods can get the operation of the pipeline more accurately, but it often requires a lot of capital investment and the actual monitoring technologies will be limited by the site and environmental condition as well. The second method is the modeling analysis method. A hierarchical structure model is established at the beginning, and the output will be determined based on evaluation criteria by algorithm and input attributes. We find 4 different types of the modeling analysis methods online. First 3 are fuzzy comprehensive evaluation method, technique for order preference by similarity to an ideal solution, grid relational analysis. In this report, we are going to focus on the first one, its analytical hierarchy process. In the next slides, we are going to get more details on that. Random forest model is our selection for using in the condition assessment. Before we go into the random forest model, we need to understand 2 words, decision tree and analytic hierarchy process. Decision tree is a graphical method to show the different choice made by the specialist or machine in form of a tree net. This approach is used in machine learning and data mining. It is widely used in many industries. For example, we use a decision tree to predict the chance of the rain at a particular time of a day. The analytical hierarchy process, AHP, is used for the predicting and examining completed problems. It is the process that defines multiple attributes issues to help the management team to make an appropriate decision. Combinations of separate performance indicators with one of the main performance indicators are done to allocate different weights for each attribute. The process of AHP is mainly used to calculate weights. Furthermore, the input for the AHP are alternatives and attributes in condition assessment. The random forest models basically combine a decision tree and analytical hierarchy process, which is the group of items that are studied based on classification and regression techniques. In the random forest algorithm, a number of decision trees are built during the process. That is why it's called a forest. It is an efficient method of classification of the data and predicting data. In this method, the prototypes are used to give the relationship between the variables and classification. RF model is an experimental method that aims at communication between the variables, and it is faster techniques as compared to other algorithms, such as support vector machine. Random forest model procedures consist of following 7 steps. The first step is to collect and extract the basic information from the basic database and damage database of the urban water network. The basic information includes pipeline attributes information, geographical environment, operational status, and spatial location. The second step is to pre-process the acquired pipeline information. For example, according to the data attributes of the impact factor, it is divided into continuous variables and classified variables. The data attributes can be the pipeline material, size, service life, and road load. The third and fourth step are to establish the model and evaluate the efficiency of the model. The fifth step is to use the model to predict the damage probability of pipeline, and then use it to grade the prediction results. Use the color and number to represent the health level. Finally, the importance of attributes is evaluated, and the team will make the right decision to maximize the asset value. Random forest model has many advantages. It provides a high accuracy result. It works well in case of large data sets. The most important thing is if the large part of the attributes are lost, the accuracy can still be maintained. RF model has well balanced the time using and accuracy. Some interesting numbers we find from our research paper. 70,000 pipes 35,000 under inspection, it will only take 20 seconds to finish one circle assessment. It's very efficient. RF is a zero assumption model which decreases the probability of errors during the process. RF model can also determine the interaction between the different attributes. It is simple to deploy and not easy to overfitting. A few shortcomings of the RF model. First one is, one attribute with more weights will have a great impact on result. Second advantage is overfitting in some classification or regression problems. But we can reduce overfitting with the use of optimal number of trees.
Another commonly approach used in asset management is known as AI approach. Compared to the traditional asset management, which is inefficient, lack of accuracy, highly depending on experts' personal experience, and requiring a huge amount of information and research inspection, AI approach is efficient, much accuracy. AI approach is a technical approach. It is based on suitable algorithm, and it is data-based, which can be commonly used in a wide field of studies. The main idea of this approach is combining AI with cloud and mobile computing system. AI techniques can be used for information gathering and processing. Researchers could collect information through taking pictures, mapping, or even let the AI do the job. Cloud computing can be used for storing captured and processed information and used further in data analysis. In addition, recent development of the algorithm and machine learning allows mobile device and computer to enable an efficient and resource-constrained calculation. The combination of AI tech, cloud, and mobile computing and suitable algorithm would eliminate manual procedures and capture a wide range of data. Those captured and processed data can be stored into the database for further reference. Hence, AI approach has become popular in asset management market recently. AI techniques help people construct more accuracy, reliable, and live portfolio. However, AI techs requires support from database. For field asset management, the incoherent updates of the database and limited information sometimes narrow the applicability of the database. Also, AI applications are expensive, which is not affordable for small business. Hence, AI techniques could only be used for a specific area. Therefore, the AI approach still needs a long way to go. Although AI approach cannot entirely eliminate manual work in short term, AI approach has an extremely large potential market in long run. In conclusion, there are a wide range of functions, methods can be conducted in asset management and convenient people in many aspects. The different methods have their own advantages, and people could choose different methods based on their requirements and values. However, the disadvantages such as lack of accuracy, inefficiency, cannot be ignored during the assessment. Thanks for listening to our presentation and have a good day. Be safe during this period.